Okay. When you're finding the distance between two functions, it's quite tricky to begin with, but hopefully we can simplify it. So when you have a line, let's say 8 and this is 5. When we find the distance between these 2 points, we could just say 8 minus 5.
Yeah.
And we would get 3. But if you went the other way around and you went 5 minus 8, you would get -3. Okay, but distance, we actually basically use the absolute value, which is in this symbol. So you don't really have to know that. It's more for AP. But the absolute value means you remove the negative from whatever value you have. So if it's -3, it becomes just 3. So the distance is an absolute value. So you can't have a negative distance. So what I'm saying is you can -1 from the other and it doesn't matter. If you get the answer being negative, it's fine. You just make it into a positive. So the next thing you need to know is when you find the distance between two graphs, this concept of saying 8 minus 5, right? Let's just make those functions, right? So if it was f of x and g of x, okay. Well, instead of saying 8 minus 5, you can just say f of x minus g of x. Okay, now as confusing as that is, you must just know that when you minus two functions from each other, you get the distance between those functions.
Okay.
So, for example, we've labeled these functions a little bit differently because, well, no, we haven't. Instead of, they've actually written them both as y and y. But if I wanted to find the distance between these functions at any point, I could simply just write -x squared plus 1 minus x minus 1. Okay, so these are the two functions that I'm minusing from each other. So in other words, the blue one is the parabola.
Yep.
And the, let's make it a, and the orange one is a straight line. So if I minus them from each other, I will get the distance between the graphs. So
from those specific points or from any point?
for now, that's it. Now that's the question. So this equation will give you the distance. Now, what we can do is we can sub in any x value and we will simply find the distance at that point. So I'm going to remember that E, the value of E, what was the x value at E? It was -2, right?
I think so.
And the value at D was 1.
Yeah.
Okay, so the x value was 1 at D and -1. And you see that's where they touch. So the distance technically should be 0. So what I want to do is I want to just get this function for a distance. So we're just going to say the distance equals. So the distance between these two functions would be -x squared minus x plus 1 plus 1 plus 2. Okay. Now let's say that I subbed in -2.
Okay.
If I put this in my calculator, I get 4. Oh, there's a minus on the outside. Oh, yes, minus. So I get there -4. -2 is +2. +2, and I get 0, which is exactly what I want. The distance at 0, at E is 0. And if I sub in D, which was 1, the point, the x value at D, I see I get 0. So this is just proving what I'm saying, that the distance between two graphs is going to be you just minus them from each other. So when you watch this video again, hopefully watch it a couple of times.
Okay.
This is very important, right? The fact that it's your blue function minus your orange function. Now you could also say orange minus blue, doesn't matter. You just remember that whatever value you get, because it's a distance, you take the positive value. So you just change it to whatever you have, you make it a positive. Okay, so we've been
when I get distance, no matter what the answer is in the negatives, I just make it a positive.
Good, yes. So although we did question B before, I'm going to do B again using this new method. So they want the distance of AB. Now, we were able to get that quite easily by just going, well, that's 1 and that's -1, so it's 2. But let's say that I didn't know that and I wanted to just use this equation, which I've now got for the distance. So the graphs minus each other. So the equation was -x squared minus x plus 2. Now what I do is at A, what's the x value at A and B?
I think it's B is the x value. X is 0, I think.
Excellent, good. -0 squared minus 0 plus 2 is 2. When we get that distance, we got 2 as AB. Because it was just, that was 1. And that was -1. And so we got the same distance as 2. So even if you didn't understand this, you just believe it blindly, right? You can just believe it and it's going to work. So just trust it. So now they want the distance of GH if OF is 3 units. So C, I'm going to redo using the equation. But of course, because OF is 3 units, we know that F value at X is -3, right? Because it goes from the origin. So it's 1, 2, 3, so it's -3. So if we just sub in here, we just sub in -3. And we get -9 plus 3 plus 2, and we get 4. We get -4. And so the distance is 4. And I'm glad this happened. Because what? We were doing blue minus orange. Right, so do you see that blue is at the bottom? So blue minus orange, we should get a negative answer.
Yeah.
Because if it was orange minus blue, of course, blue is lower, so it would give us a positive.
Yeah.
Okay, now this,
so it doesn't, this method of finding the distance between the two functions, it works like any point on the graph.
It does. It works at any point. All you need to do is sub in the x value, and it's got to be a straight line down. It's got to be a vertical line. So it won't work if we try to do this.
Okay.
Because it's different x values, right? There we would have to use the distance formula, which is that a different coordinate. Remember the distance formula is the square root of x squared minus x2 minus y2, x2 minus x1 squared plus y1, that distance formula.
Okay. So it only works if it's straight down.
Exactly.
Like in alignment. Okay.
Good. Now the D is the coordinates of J and K. The distance JK is 4 units. So now they've actually given us the distance. So what we do is we simply just put, well, the distance is 4, and we make that equal to our distance formula. and solve for x. Okay, so do you see the others? We were just substituting in a value for x.
Yes.
Now we are substituting a value in for the distance because they're not telling us the x values, are actually now telling us the distance. And so
Okay.
if we get the x values, we'll get the x value of these coordinates, j and k. Okay, so let's take the 4 across. So we get x equals 0 equals negative x squared minus x plus 2 minus 4. We get negative x squared minus x minus 2. Now this is easier to deal with if we just do what to this?
If we change the sign.
Excellent. Yeah, just change it to plus. And so this function is I've done this right. Negative x with plus 2. Oh, it's minus 2, right? Because minus 4 minus 2. Oh, no, that's right. Okay, what's actually going to happen is the distance is 4, but remember we're doing blue minus orange. And it should actually be orange minus blue for this one, because blue minus orange will give us a negative value because we're minusing a bigger number. So blue, say blue was negative 2 and we minused 1. Negative 2 minus 1 would be minus 3. So we actually have to make this a minus 4 here. So we just got to be careful with these signs. And so this ends up becoming plus 4. And so this is then plus 6. And so this changes negative, negative. This changes to then minus 3. Minus 6, I beg your pardon. Okay. And then we get x plus 3 as our brackets and x minus 2. So this is factorizing. And so our x's is x equals negative 3 and x equals 2. Now, let's just explore this quickly. So these are x values. So the distance is 4 here. That's what they tell us.
Yeah.
Now, that's not the only place where the distance is 4 on the graph. We actually got the other distance over here was 4, 2. And so do you remember when we got that answer of negative 3 in the, when we tried to do this the first time, when we did GH the first time?
Yes.
Well, we can see that this is negative 3. It's over here. And so that technically is just there. And we know that that distance is 4. So when we do this, we often will get 2 answers because there's more than one place where the function is that distance. So it's a distance of 4 there, and it's a distance of 4 there. Now,
are we
yes.
Are we not allowed to assume that points are lined up when we do this?
Points are lined up underneath each other.
No, like lined up like horizontally. Like if we know that like that distance, what are we trying to find? Oh no, okay, never mind, because we're trying to find the point K and J, not the distance.
Yes, we want to find the point.
Right.
So we actually know now, because the 4 was the G was, this is the G. So I'm going to do it in green. This is the point, obviously, we're dealing with, the X equals 2, because that's where X is positive here. And so if we want the point K, we simply just sub in 2 into the parabola, because that'll give you the Y value. Okay, so I'm going to carry on the left-hand side. And I'm going to say the K value, the Y value of K is going to be that 2, and it's on the parabola, right? So the parabola is the blue, which is this one is the parabola, right? So that's why I sub the 2 into here.
Okay.
And so now I get -3, which makes perfect sense because it's all the way down here. Now I almost know immediately, because this distance is 4, I know J is going to be then 1. Because -3, -2, -1, 0, 1 will give us the distance of 4. But I'm going to not, I'm going to still get the full one. So K is 2 and -3. And just for this question, even though I could simply now go say J is now 2 and 1, I'm actually going to use the graph just to double check. So we can do it in purple. So no, it was orange. No? Straight line was orange. So Y equals 2, because X is 2, minus 1 will be 1. And that works. Okay, so we've got that 1 there. And we've got the K in green there. Okay, and so the coordinates of J and K are 2 and -3 and 2 and 1.
Where did we get the 2 from? Oh, no, never mind.
The 2 we got for quite a long process, but the 2 we got from using the distance formula. So in other words, we minus the graphs from each other. And then we have an equation for the distance between the graphs. And that'll work at any value of X. And so we went, right, well, what value of X do we need in C? Well, we used -3 because they asked us to. In D, they didn't give us a value for X. They just told us the length. And so then we put in the length and then solved for X. And that gave us 3 and 2.
Okay, yo, this one is very confusing.
It's very confusing. So especially because this is, it takes more than one watching of this to get it. So
yeah.
In fact, I remember, I think going and tutoring a matric, and I hadn't done matric in a few years, and I'd forgotten this. And I was trying all sorts of things to find this distance, like Pythagoras, and I was using the distance formula, and I got it, but I got it a long, long way, and then I looked at the memo, and it was just like that graph minus that graph, sub in the 2. So, so watch this. I'm going to stop it there, and you can watch this video again. We'll go on to the next one. And then if you still got issues, we can go through it again. But hopefully when you watch it a second time, it'll be easier to understand.
Okay. Yeah, that's all right.
So it's a good job we're recording it.